Okay, guys, welcome back. We are going to talk a little bit about building a greener future and living in a greener world now, about architecting in the cloud for sustainability. So, Sohan, welcome to the stage.
You check.
Yes, by now you should learn to clap. Somebody tried. Okay, take it away.
All right, folks. First of all, welcome to this talk. My name is Sohan Maheshwar. I'm a senior dev advocate at Amazon Web Services based in Amsterdam. And this is my first time in Vilnius at BuildStuff as well. But unfortunately, I have to start with some not so great news, right? And that is scientists say that there's only a limited window for us to reduce global warming by 2050, right? And I'm sure if you're following the news, you've heard about climate change, you've heard about how this is affecting us. What I'm here to talk to you about is how you could architect in the cloud for sustainability. Now, technology is at the heart of everything that we do. So we really have, we can make a big impact on this. Right? So what I'm going to talk to you about today is your sustainability journey in tech and how you start off by understanding the terminology about how what you build actually has a carbon footprint. Right? Every time you swipe on your phone, technically there is a carbon footprint to doing that. Right? So I'm going to talk to you about understanding that, about how you can change your architecture in the cloud to optimize for sustainability, and how more often than not, this reduces your costs as well. So it's win-win. And of course, I'll end by talking about the sustainability transformation journey. Now, there is a very real environmental impact from doing this, right? It's a very positive impact that we will see by doing this. But there is another reason, apart from saving the world. The other reason is it actually drives business growth. There are many reports out there, and I'm picking one from Accenture from last year, which actually says that these companies at the twin intersection of digital tech and of sustainability actually can drive 2.5x growth. Right? So if you as a business or as a customer or as a technology company, if you adopt these sustainability trends, it's not only beneficial for the earth, but also for you as a business. So today we'll be talking about a lot about something called the GHG protocol, or the greenhouse gas protocol, right? And it defines how to convert greenhouse gases to a carbon dioxide equivalent and 3 scopes, right? The question that I get asked the most is, how do you know, or how do you calculate what the carbon footprint of a workload in the cloud is equal to, right? How do you go from one to another? And to understand that, you have to understand these scopes, right? And these scopes essentially define carbon dioxide emission. So the first one is called scope 1, which is any fuel that is consumed at the source, right? So if you have a car and it has gasoline, petrol, whatever you call it, fuel, and if you're burning it, that is scope 1. Similarly, if you're barbecuing and you're cooking, you're using oil, that is scope 1 because you're using fuel there, and that's the source. If you electrify all of this, you're essentially reducing that scope to 0, right? So that is one way of looking at scope 1 emissions. Scope 2 emissions is the energy used anywhere, right? And this could be something like an induction range, it could be in a windmill. Essentially, any form of electricity used is counted once as a scope 2 emission. Yeah, again, scope 2 emission. So you can have any renewable source of energy, and it will be counted once as a scope 2 emission. And scope 3 essentially is everything else, right? It depends on your business. If you have suppliers, inventory, consumers, all of the energy consumed there is counted as scope 3. So you have scope 1, you have scope 2, you have scope 3. Let's put all of this in a traditional data center. Right? Of course, 10 years ago, most of us used tech in data centers, and the energy consumed in that data center was a mix of scope 1, 2, and 3. For instance, you probably had some backup generators that consumed fuel, so that would be scope 1. The data center probably used things like wind farms and power pylons as scope 2 energy, and everything else around that was scope 3. Quick question, how many people here use the cloud on a day-to-day basis? most of y'all. Well, congratulations, folks. By using the cloud itself, you are already more sustainable because studies have shown that there's at least an 80% reduction of energy usage when you compare a traditional data center to an AWS workload. And this is because how the cloud is structured. Right? In the cloud, there is more utilization, there's dynamic resource allocation. So inherently, the cloud is more sustainable. But what we are going to talk to you is how you can go from that to being even more sustainable in the cloud. Okay, any AWS users here, and has anyone heard of the shared responsibility model? Anybody? Few of y'all? Okay. So what it essentially says is, when it comes to security and compliance, the responsibility of security and compliance is shared between AWS and the customer. Right? So AWS takes care of security of the cloud, and the customer takes care of security in the cloud. Right? And we give you the tools and services to do that. We look at sustainability in the same way, right? Where AWS is responsible for sustainability of the cloud, and the customer is responsible for the sustainability in the cloud, right? And that's what we're going to talk about today. Very quickly, just a quick slide on how AWS is working on sustainability of the cloud. We make sure that all the water that is used in our data centers, they have evaporative cooling, they're recycled, and there's on-site water treatment. We make sure we're using renewable energy to power these data centers. And in fact, by 2025, we will be using 100% renewable energy. And something that might be of interest to you is the Amazon Sustainability Data Initiative, or ASDI. We're giving all these data sets about sustainability, so weather patterns, water patterns, all of it for free. So you can use it in your reporting, in your hackathons, whatever, right? So check it out. It's all on GitHub, access to some pretty cool data sets. Today, though, we are talking about sustainability in the cloud itself. And how I would define that is a continuous focused effort on energy reduction, right? And doing this in the cloud. I think the key for me here is the continuous focused bit. I meet with many customers, and sustainability is at the top of mind for everyone, but it invariably becomes something they do once a year. Start of the year, everyone's like, hey, we need to do the sustainability thing. Let's have like a committee meet, and then everyone's forgotten about it. Yeah? Because we all have important things to do and great products to build. So a chunk of today's talk will be about how this has to be a continuous focused effort, right? And I will be talking about all of this in these 6 lenses, right? We'll be talking about choosing regions, user behavior, data, and so much more. All right, so let's kick things off and go with region selection. For those of you all familiar with using the cloud, you typically put your cloud workloads in what's called a region, right? A region is a geographical region, of course, and this is where any cloud provider like AWS has their physical data centers, or they're called availability zones, right? And typically, for instance, say a bank in Germany would like a region to be in Germany because they might have data residency rules and so on. But there are different reasons for choosing different regions. It's surprising for many people to hear that choosing your region itself can change your carbon usage. For example, in the US, it's about 3.6 times more efficient than a traditional data center, whereas in Europe and Asia Pacific, it might be up to 5 times more energy efficient. And this comes down to the scope 1, 2, and 3 that I spoke about earlier, right? So you might be building in the US, but just by choosing a region in Europe or Asia Pacific, if your requirements allow it, immediately allow you to be a little more sustainable right there. Right? So depending on your requirement, depending on your agreements with your customers, you can just choose a region accordingly. Let's talk about user behavior patterns, right? And I think as product owners or as product builders, we all look at how our users behave and build products for that, and when they use your product and how they use your product. Let's talk about how you can actually look at this and then build something that is a little more sustainable. I'm going to give you an example of a cloud workload where you can optimize capacity for sustainability. Right? So say you have a cloud workload and your customer has said the requirement is it has to fail over immediately. What this means is if something happens and it goes down, you immediately have to have a working backup running, right? So mission critical application, immediate failover required. What I see many customers do would be something like this. They would deploy their workload up to 50% in one availability zone and have the backup running in availability zone B at 50%. So assume availability zone A goes down, they can shift that workload to availability zone B and have immediate failover. Right? Works fine, it's all good. But here's the thing, the utilization is super poor, right? There's only a 50% utilization both in availability zone A and B. So you're not really optimizing this capacity to be a little more sustainable. Instead, you could potentially do this across 3 availability zones using 2/3 utilization, right? So in this case, if availability zone A goes down, that workload can be split between B and C. So this way, you're really achieving a higher utilization, right? And you're optimizing your capacity for sustainability. All of this, though, comes down to the requirements that your customer has with you. Because maybe you want to optimize resiliency for sustainability, but your requirement is a non-immediate failover. Right? Your requirement doesn't say there has to be something up and running soon. It can take its time. In which case, you might want to design and architect your system differently. So you can actually have full utilization, 100% in availability zone A, and have cold capacity running in availability zone B. Right? If something happens to availability zone A, it can take its time and you can shift your workload to availability zone B. Again, this is possible because of the requirement, which is non-immediate. So based on your requirement, you can actually optimize for sustainability. This comes to another point, which is when you're actually in the design phase, you can negotiate impact-friendly SLAs, right? Service level agreements that actually are carbon reduction impact friendly. So this may increase, say, in response time, but can also reduce your cost. All right, let's talk about software patterns. Right? Again, we're talking about sustainability in the cloud. So when it comes to software patterns and how you develop and architect your software, there are things that you can actually do to optimize your processes and optimize for sustainability. One way of doing this is actually by reducing peaks. Right? So when you're when you're provisioning capacity, unfortunately, what we do is we end up provisioning for the peaks. Right? You're like, okay, this is my peak usage. Oops, this is my peak usage. So I'm going to provision a little more, just in case this is the cloud workload that I need. But as you can see, the average is fairly low. Right? And this is what invariably ends up happening in the real world. So if you can find a way to reduce those peaks, your provision capacity decreases. Right? And again, that is more impact friendly. Your carbon usage decreases. So how do you actually do this in a very practical way? Well, here we go. Does anyone know what this is? This symbol? Anyone? No? Okay, so this is a cron job or a cron tab to run, like processes automatically. And I don't know if it's a habit or if it's just people do it, but everyone actually runs this cron tab at midnight every day. Right? By default, everyone tends to do this. But what actually happens is this drives up usage a lot. Right? There's no fixed reason for us to do this only at midnight, but so many synchronized jobs at the same time can actually drive up usage of those peak workloads. So just by changing that cron tab or that cron job to a different time can reduce that peak of usage. Right? And that way your provision capacity also reduces. And imagine many customers doing this at the same time. Again, when you're using the cloud, we're all technically using the similar hardware. So many AWS customers using that, it's going to drive up peak workloads. And it drives up the total AWS capacity needed as well. So just change the timing of that. Another way to do this is by using queues and buffers. Right? You can do things asynchronously and you can schedule things as well. When talking with my customers, it's almost a light bulb moment for them to realize that having a queue or an event store has no impact on the final product or their business logic. Yeah. People again think that, oh, something has to be processed immediately, but then you're driving up those peaks which invariably slow you down anyway. Right? So having queues, having buffers has little to no impact on your final customers and can drive down those peaks. All right, let's talk about hardware patterns. We spoke a bit about user behavior. We spoke a bit about software as well, but choosing the right hardware in the cloud can also make a very big difference. Things have changed in the past 10 years or so, right? Earlier we had just very similar types of instances that you ran for every purpose. So say you were doing graphics, say you were doing analytics, say you were doing, I don't know, just image resizing, you would use the similar types of instances, but things have changed now. Right? There are so many different types of instances that are purpose-built for different products. So if you're deploying an AI model, there are instances meant for that. If you're doing something that's highly GPU dependent, there are instances for that. If you're doing heavy data processing, there are instances for that. And what happens with each of these is that these instances are designed for those type of workloads, so they're immediately more efficient. Yeah? And that again means lower carbon footprint and also maybe a reduction in cost. So think about actually how you could use these different hardware. Just to give you an example, this year and maybe end of last year, Amazon launched the Graviton 3 processor. Right? And this is the third generation of the Graviton processor. It's custom-made AWS with a 64-bit ARM processor core. And just by migrating to Graviton 3, it's optimized for cloud-native workloads, and you can save up to like maybe even 60% of your energy just by shifting to Graviton 3. In the same vein, there is also the inferentia chips, which are used specifically for AI ML models. So if you're doing anything in the AI ML space, do check out the inferentia chips as well. Again, the idea is to use something that's purpose-built for the thing that you are doing. Data, our favorite topic. I think every business out there generates a ton of data, right? Everything from logs to observability to all of that. It's a lot of data. And we have to look at classifying this data to actually be more efficient in how we use and process this. A lot of this comes down to starting at the policy and at the auditing level itself. Right? Again, this has to be a continuous effort. It has to start from the beginning. So think really hard about things like lifecycle policies, how you can actually have life cycles for your data over a period of time. It's not just about generating that data and throwing it into an S3 bucket and letting it live there forever. Right? You're just paying for nothing. So why do that? A good way to actually reduce this is by using data classification and lifecycle policies. So to give you an example, say you have an Amazon S3 bucket, standard bucket, you can actually write policies in code like this. Right? So this is fairly simple. It says after 3650 days, you can transition this into a deep archive, which is basically saying after a long period of time, just put it into an archive, and after some time in the archive, you can also delete it. Okay? And again, this is not something that you would do once, but start at the policy level itself. So when you're building out your cloud systems, when you're designing your cloud systems, these can be your policies. A good way to sort of look at data is to look from hot data to cold data. Right? Where hot data is data that is accessed very frequently. So for that, you might need like millisecond access. You might want to save it in more than 3 availability zones, for instance, because that is data that is being accessed frequently. For data that's kind of inactive, you're not using it as much, again, you might need millisecond access, but only in one availability zone. There is a tier in S3 called one zone IA, or infrequent access. But for data that is not accessed too much, you can put it in something like a S3 Glacier Deep Archive. And this is data that won't be accessed too much. The retrieval time is maybe a few hours, But then again, you're saving costs and you're reducing your carbon footprint as well. And also, make sure you delete any data that you don't need. Right? Again, very often we end up just storing it because, hey, what if we need it? But if you have policies for this, you can automate this entire process. Right? And in fact, with AWS, you don't even need a policy. You just click a button, and this will automatically happen for you based on days that you set for hot to cold. Also look at how you can actually store your data in different formats, again, that are purpose-built. Again, when we're doing things like, with a lot of data, we then tend to use CSV formats, but think of using things like Apache, Parquet, or Orc, or Avro. Right? These are meant for efficient ways to store large amounts of data and retrieve them efficiently. And some are row-specific, some are column-specific, so just by storing it in these different data formats to suit your data, you can be more efficient, and you can also, again, maybe save some money in the cloud. Also, with data stores, you want to look at purpose-built databases. I'll give you an example. If you're building something to do with either stocks or IoT devices, this generates a lot of data that changes over time. So you might want to think of using a time stream database or a time series database as opposed to an old school relational database for which it's simply not efficient enough. Yeah? And these things actually make a huge difference. And I'll give you an example. Right? At AWS, for an internal service, we actually just changed our compression algorithm from gzip to zstandard. Right? Literally just changed the compression. And we actually reduced storage by 1 exabyte. That's 18 zeros in 1 exabyte. That's 1 million terabytes, right? Or a really, really big hard disk. So literally just by changing a compression algorithm, we were able to reduce our storage by 1 exabyte. Yeah? And these things actually go a long way in reducing your carbon footprint and maybe being more efficient with costs and resource utilization as well. So you've done all of this, right? You've done all of this, and most modern tech companies, which I'm sure all of you all are part of, have development and software life cycles. You do the whole build, prod, all of that. So it's not just about doing all of this in your production, right? You want to apply this to your entire software development life cycle. And this again makes a big difference because in the modern tech world, we like to iterate fast. We like to build things like CI/CD pipelines. So actually having these processes throughout makes a big difference. And again, I'm giving an example of something we did at AWS. AWS has an SDK for JavaScript, right? It's used a lot anytime someone uses Node.js in the browser to access something in the cloud. We use the AWS SDK. So in version 2 of the SDK, we had all services, right? Think of many modules in that one SDK. And we got feedback from the community. So we actually changed it from having all those modules to making it modular where you could choose which modules you wanted. And as you can see, the build size reduced by, quite a bit. Yeah, just by making it a little more modular. And we were able to reduce the bundle size by about 75%. Now this goes a long way into millions of people using it at scale, right? So when you have build artifacts that are going out into your build servers, into your staging, into your test, into your prod, think of how you could reduce that build artifact size. Remove those unwanted NPM modules that you're not going to use. And you'll actually see a difference, again, in your carbon footprint, but also in other resources that are being used. All of this makes sense, I think, in the sense that people do this in their production, right? We've seen people do this in their production, but we're borrowing a term or a concept from the world of DevOps, which is the concept of a left shift. Has anyone heard of a left shift here? No? Okay. So in a left shift, you basically take all of these processes that you do in production, and you bring that all the way to everything from design. Right? So right from your design stage, you're building these processes so that it becomes part of your culture. Right? It becomes part of your auditing, of your policies. So you really want to think about sustainability from design, implementation, staging, and then automatically it'll be part of your production as well. This is hard for us to do because this is not part of the metrics that we look at on a day-to-day basis, right? I'm sure all of us here do daily stand-ups, weekly calls, yeah, everyone? Yeah? In how many of these calls do you actually talk about sustainability? And my guess is not too many. And it was the same with us as well. But now we're starting to think a lot about sustainability with our customers. We're starting to have that conversation, and metrics plays a very, very important role in that. The way to look at metrics is it's quite interesting, right? So typically in the cloud, you will look at these functional requirements like compute, data transfer, utilization, storage. These things can work against each other, right? For instance, do you store more data in different parts of the world, or do you do data transfer from one region to another? Yeah? Or do you store and cache a lot of data, or you do computation on the user's devices? Right? These are very difficult questions for us to answer when we're looking at metrics and design. Similarly, sustainability sort of plays against many common non-functional requirements, right? Like things like cost, availability, and response time. I gave you an example earlier of how response time can be reduced, but your sustainability metrics can increase. I'll give you an example of how cost and compute can play against each other as well. Do you do a lot of the computation in the cloud, or do you say, let me do the computation on my users' devices, but then they'll have to buy a new phone every year? Right? So these things sort of play against each other, so it's very important for you to understand how these sustainability metrics play against your common non-functional requirements. And the mental model that we as builders and we as technologists should use is we need to maximize utilization in the cloud, right? Try and maximize it via things like, and maximize CPU efficiency via things like software design, what I'm speaking about. At the same time, we want to eliminate all idle resources, minimize data processing and data storage, and have policies around it. When it comes to resources, a good way to really think about it is not just look at overall resources consumed, but resources per unit of work, right? Or like saying, oh, this is the number of gigabytes that we are storing versus this is the gigabytes per customer, right? And that way you actually normalize your sustainability metrics and you get a good sense of that. I've spoken a lot about sustainability and metrics, but how do you actually take a look at what these metrics are? So you can take a look at your carbon emissions report. At AWS, we have this thing called the Customer Carbon Footprint Tool. Now, if you have deployed on AWS, just look for the Customer Carbon Footprint Tool. You get detailed metrics about your carbon usage. So how many megatons of carbon you're using per service, per region, what your savings are, all of that. There are also open source tools available. I came across this thing called the Carbon Aware SDK. So if you're not on AWS, you can check out these open source tools too. But this is the first start, right? Because without metrics, there's no way for us to know if we're doing a good job or if we're reducing our carbon footprint, right? We can just do it, it's just there in theory, and you're not showing this to leadership and you're not showing an impact to your customers, right? So the first step is to start measuring. A good way to go from measuring is actually establishing KPIs around it. So with our customers, we do this, which is report it using the AWS cost usage reports, and then we have data warehousing and show it in dashboards using QuickSight, right? And this is just in the reporting phase. I'm guessing people here are like, I'm not really a dev, or I'm not really an architect, so can I really do anything about sustainability? And this really should be every team's goals, or part of every team's goals. It's not just a CTO or a team lead that has to do this. For instance, an architect or a dev can actually design for sustainability, but someone in DevOps can optimize for efficiency as well. I just spoke about reducing your build artifact sizes. And of course, your senior leaders can report all of this data to leadership and to your customers and actually show that journey from when you all started. Again, something AWS specific, but there is something called an AWS well-architected sustainability pillar, right? So the well-architected review is this framework in the sense of operational excellence, cost, security, and reliability for any cloud workload, and we added sustainability to it as well. So you can review how sustainable your workloads are using this well-architected review, and of course it's free to do. All right, a quick summary of what I just spoke about. All of us are part of this journey, right? And the start of that journey is understanding all of this terminology we spoke about, understanding what your carbon footprint is, and then really optimizing to reduce that carbon footprint. But it's also about showing these metrics, right? Understanding this, understanding how it could also reduce your cost, and showing the value of that to leadership, customers, whoever. I think in the last decade or so, we've spoken a lot about digital transformation. I've been in this space for a while. There's so much we've spoken about, going digital transformation. This decade, right, I think is really going to be about sustainability transformation. There's so much demand from customers, from businesses, and like I said, there is business growth to it as well. So we're really moving into this journey of digital transformation. If you look at worldwide metrics, right, there is about 50 gigatons of carbon dioxide equivalent of emissions worldwide. That's a lot. And actually, if you look at only ICT or information communication technology, doesn't seem like too much, right? There's a high or a low estimate of what that percentage is. But here's the thing, technology and software is really at the heart of everything we do now, right? So it's up to us to really think outside of that and see how much of a positive impact we can make in this. And honestly, the next steps for all of us is to just start the conversation, right? Just start the conversation, start talking about it on social media, start talking about it in community meetups, but most importantly, in your businesses as well, because it's high time we need to have this conversation about sustainability in tech. All right, so that was it from me. Hope you learned something new. I'll be around for a while as well. Happy to connect online too. And yeah, if there are any questions online or here, feel free. Yes.
Wait a second, I'll bring you the microphone. He talked for me. I didn't even have to say ask the questions. Here you go.
Yeah, thank you for the talk, Sohan. So can you give some examples where increased sustainability can also increase the costs?
Can also increase the cost. Yeah, absolutely. So there was this example here. Let me just go back. Has to be a quicker way to do this. Yeah, in this slide, right? So when you're playing against cost versus compute, for instance, right? There are cases where you can increase computation in your workload in the cloud and reduce the computation on a user's device, for instance. So that way there's more happening in the cloud. So technically you're using way more resources, right? So it can play against any of these things. More often than not, you will end up saving money. But there are some ways where you say, hey, I can be more sustainable and not get my users to buy new phones every year, but then I take the chunk of the compute and do that in the cloud, and then I only pay for, like, say, data transfer. Yeah.
I think this will be a little bit harder, right, to like, let's say, play against the management, because especially right in the current situation where the inflation is high and the economies are not doing so great, everyone is right now focused on to reducing costs, and I think most of these initiatives have a direct impact also on sustainability, right? So you end up increasing the sustainability, but maybe there are not a lot of these use cases where sustainability could also increase the costs, right? So
yeah, no, fair enough. But like I said, I think most cases, because you're reducing your usage and you're optimizing for that and you're eliminating unwanted resources, your costs also decrease. So more often than not, that's what happens. Yeah.
okay.
Thank you. Any more questions in the audience? Anyone? I can see anyone. No, it seems not. And Pine is also resting, maybe
Okay.
because we have that awards event
Yes.
going on and starting about now. It's a little bit late, but it should be starting. So if that's it, last call. No one, no one, no one, no one. Okay, so thank you very much.
Thank you.
And so yeah. We're gonna talk in 10-15 minutes a little bit about Tales of Data Architecture Evolution, but also, again, I'm reminding you the event of Lithuanian CTO of the Year Awards are about to start, or just started. I don't know. I haven't been there.